Hi, welcome to Prediction from the Start to the End. I'm Dr. Denise Dahman, the creator of the Gray Cell Value Algorithm. It's a new method for solving a classification problem. In this video, I would like to welcome you to Prediction from the Start to the End. It is the third element from the Big Bang of data science in its first edition. If you have missed to learn about the Big Bang of data science or DAHMAN'S Phi Services initiative, please make sure to check the documentation from the official website. Now, about the outlines and the subject that we're going to learn about in this book, in addition to a screencast about pre-recorded lectures, please make sure to check the materials below. Once again, welcome to Prediction from the Start to the End. I assume you have completed the first two elements from the Big Bang of data science. These are research and analysis from the start to the end. The outcome from those materials was an analytical model in the form of a product that is good and successful. But we knew back then it wasn't intelligent. We said we needed a future element to be factorized in its formula or equation in order for that product to be intelligent. That's exactly the main aim of the outline of this material. Now, before I walk you through some of the competitive advantages about this material and what diverged this material from so many other books speak about the subject of prediction, first I have to clarify some misconceptual understanding about the title itself. The main title of this material is prediction. And what does prediction mean? Well, prediction implies the exact same meaning of the hype around the phenomena of artificial intelligence, machine learning, deep learning, or any kind of jargon and terms of that sort. But the actual fact is the same. What does prediction mean? Prediction implies telling us something about the future. Now, this kind of telling should be educated enough and somehow to be accurate. Now, the question is, how can we guarantee that kind of accuracy? And what is really happening in that kind of a black box tell us something about the future? Now, first of all, if you would have to check the definition of AI or machine learning, you might encounter with the definition that the machine learned by itself from that large amount of historical kind of data. Well, you see, the definition itself from one angle could be really misleading. First of all, there is nothing called a machine can learn by itself. It will never happen. But the idea is there is some sort of a mechanism that enables the machine to operate and somehow, and then the magic of prediction could happen. Now, in order for me to share with you the competitive advantages, I would like to start up with this story, which is, I call it, text editing and you. Let's assume that you are an author of some sort of a text or a manuscript, and you would like to do some editing on it. Of course, your choice would be to choose one of the available software that offer you the features where you can actually edit your text. Let's assume by the end that the features this software offers you were more than enough for you to actually execute the editing task. Somehow along the line, it turns out that specific task you needed while you are doing the edit was not enhanced in any kind of feature the software offers you. What would you do? Perhaps you're going to look for alternative kind of software that this feature or customized kind of feature you're looking for should be offered by that software. The dilemma arises if there is no such a software exists and the customized task you're looking for, it's just not enhancing any features any software offers in the market. Then what would you do? Well, perhaps if you don't have the ability to do or to create any kind of features on that sort, then most likely you will be restricted within the framework of any available advanced kind of software in the market. That's exactly the point what I'm trying to say here, that your ability to understand that kind of a black box in the form of a software or a framework or whatsoever, ability to understand what are the elements inside that kind of a black box and the component of it, it gives you the power of creating your own black box in case of the feature you're looking for or the customized feature you're looking for is not available in any of those solutions in the market. Well, that's exactly the first fundamentals on the outline of this material. Essentially, this material leads you to unlock the door of that black box and try to look inside each and every element and component within it. Now, first of all, you have to understand mathematics. Mathematics is the actual language that machine learning or artificial intelligence or prediction or any kind related to that sort understand. Why mathematics? Because mathematics able to transform any form of any kind of a problem into a set of numbers. And once we have the set of numbers, then we can read within the line the structure, the behavior of those numbers, and then we can actually extract patterns that are hidden within those form of numbers. That's why the first thing this material tried to show you how important mathematics is from a wider perspective, in form of departments of mathematics, foundation of mathematics, philosophy of mathematics, and so on. But next, in the most important part, you are not here exactly to learn about the rigid of mathematics in a general way as an independent language. We're here actually to choose some of those materials from the domain of mathematics that enable us to create those kind of AI modules. And that's exactly the second important competitive advantage. I'm going to introduce you to what you must know about mathematics in order to create those AI. So I'm going to select the most important subject from mathematical perspective that you can learn about them. Now, guess what? The point is not only to understand the rigid or the abstract meaning of them from mathematical perspective, but how actually you can apply them into a real life problems. And that's exactly the approach this material offers you. To check every title from mathematical perspective and choose an applied example and match them together to actually execute the solution from mathematical abstract perspective into an applied one. Now you have all the tools you need in order to create those AI modules, machine learning modules, or predictive modules in general form. That is the use of mathematics. The question is, how can you start? That's where I introduce you to the next important competitive advantage of this material, map of prediction. In this map, I share with you a very methodical steps and guideline on actually creating different type of AI modules under different kind of terminologies using different kind of algorithms and methods. The most important part here, what I would like to emphasize, some of those terminologies or frameworks are used as the representative on the meaning of AI. Let's take an example. Imagine if your problem to work on something related to computer vision. Now, the public usually, when they hear the problem of computer vision, the first kind of things come into their mind, certain names of a framework, say, for example, CNN or convolutional neural network. Now, CNN is a framework. RNN is a framework. Even deep learning or neural network is a framework itself. Unfortunately, many people misunderstand the meaning of AI or machine learning just within the boundary of those frameworks, which is not right at all. That's why in this map of prediction, I walk you through most of the available frameworks, algorithms, and methods that somebody needs in order to create their own AI module. But at the same time, we'll also be discussing some of those available framework in the form of packages and tools. For example, the TensorFlow, which contain a lot of libraries actually discussing so different kind of modules that had been already packaged for us instead of reinventing the wheel. However, the main point here, you are going to become an independent AI modules creator. Last but not least, we're going to actually discuss every kind of abstract and different outlines using Python to kind of line of codes, and then we see the result by ourselves. However, some of us might come from different background that they don't really have much of the knowledge that is enough at the first place about learning how to use the syntax of Python as an independent language. That's why there is an appendix to this book, which is another competitive advantage I offer to the audience that are interested to participate in this program. Where in this appendix, I'm going to walk you about Python from the start to the end. In this appendix, you're going to understand everything you need about Python. In addition, we're going to discuss some of the most popular libraries such as Pandas, NumPy, and also TensorFlow. By the end, I could guarantee you, as you have completed the entire material step by step being walked through, you can consider yourself being able by the end to create your own predictive module from the start to the end. You can also utilize some of the available ones, and you add your own customized module on it. And you have to believe me when I say, in the very beginning, I said I am the creator of a Berry cell value algorithm. Now, how did I come to create that algorithm or that method for solving a classification problem? It was actually from my understanding of the outlines that I'm going to share with you. By the end, I would like to thank you for considering to participate in this program. And I hope whatever the outlines are in there is going to contribute to your endeavor. So I look forward to your participating. And please, if you have any questions, do not hesitate to let me know. I will make sure to get back to you. Until then, stay good. Cheers.